Hello everyone, welcome to Chaudhary Data World channel. Today I am here with very fundamental topic that is architecture of a Spark. We'll be watching that how this Spark is related to PySpark. That means where the PySpark comes into picture. All these things we'll be watching in detail, and it's going to be a very short video, an informative video on the architecture, complete architecture of the Spark. So let's get started with the video. Here we can see that we are having three basic chunks, right? That means first one is the driver program, another one is the cluster manager, third one is the worker node. So worker node may be multiple here. Coming to the driver program, we can see that we are having a Spark context here. So if you are aware of that two things, here it is only written Spark context. It may be a Spark context or a Spark session. So basically this driver program, we will be in next slide we will be watching that what its responsibilities, then cluster manager's responsibilities and worker node. So let me explain you the overview how the if suppose some code is given to the whole Spark, then how it is getting executed over that. So whatever code you are writing, those code are getting taken by this driver program. Now this driver program is analyzing the code, and then in just it just pass the information to the cluster manager also with the executors. So basically it passed the information to cluster manager. Now what's the functionality of cluster manager again? So cluster manager is something in between which sees for the hardware requirements, that means storage, CPU and all. So all these things getting managed by cluster manager. Once that thing is managed, that how what all things to be allocated to the worker nodes, you can assume like this, that suppose you are having a data set, a big data set, because if we are reading Spark or PySpark, that means we are more focused and bothered for our big data set problems, right? That means we want to analyze or give transformation over the big data set. So this, when big data set is given, when we write code for that big data set, that is given to the driver program first. That code is then analyzed by the driver program. Spark context or a Spark session is getting created over here. Once those session is getting created, it is passing the information to cluster manager that hey, I am having one data set, and that data set we need to have just have some transformations to be applied over that particular data set. So cluster manager now sees that what all executor nodes, that means worker nodes. Worker node you can assume like this, that there is one computer here, another computer here. So there are multiple computers into our this. It can go till right now we can see that we are having two worker nodes. So this can't be fixed. It can be n number of worker nodes, whatever as per the requirement. Worker node is nothing but the laptop. Suppose you are having a virtual machine. On that virtual machine, you are having a data set to be analyzed. So that virtual machine will be a single machine. That means that whole big data set can't be analyzed, or if it will be analyzed, it will be a very slow process. Just to make it fast, what we are doing, we are computing that whole data set transformation on different virtual machines by dividing that data set into different partitions. Suppose you are 100 data into your data set, that means if you are having 5 worker node, that means 5 virtual machines. It will be most probably, or it depends on the cluster manager as well. it will divide the data in on 20 basis. That means 20 data will be provided to worker node 1, similarly to 2, and then 3, and so on. So this particular worker node, it is also called as executor. That means it contains executor which is having, basically, suppose in this particular worker node you are having four, you must be aware that today whatever virtual machine or laptop it is coming, it is having multiple cores, correct? So those multiple core, on the multiple cores, this executor you can see, right? The executor is sitting over there, which divides again those 20 data coming from that data set into multiple cores. That means from here parallel processing goes ahead. For in Databricks, this worker node or the executor, it is a single executor over there. And it may have multiple cores into it on which it will be divided. Moving ahead with the literature of this driver program, cluster manager, and worker node, we are having second slide, in which driver program, it is nothing but runs our main function. Now it must be clear, or if it is not clear, if we will see the responsibilities, that means it maintain information about a Spark application. Whatever information, it is just gathering those information for the Spark application, and that driver program is having track of that. It responds to user input, whatever input, if suppose you are giving, it responds to that user input, then analyze, distribute, and schedule work across executor. That means it just analyze the whole program which user has provided, the whole code for that transformation which you have provided for that particular data set. Whole code will be analyzed, it will distribute and schedule work across executors. Hope you got this particular point. Coming to the executor, executor is nothing but this particular one. So executor is responsible for carrying out the work that driver program assigns them. So whatever driver program is assigning work to the executor, it is just able to complete that particular chunk of task, whatever it is getting assigned to that executor by the cluster manager and the driver program. Executing code assigned, reporting state of computation back to the driver program. Of course, it should be, this mechanism should be there. Suppose you are having 20 data set, and if you are you are having 100 data into your data set, and 20 it is having divided, and if suppose some transformation it is going on, this particular executor should have the information that till where it has been executed, till where the transformations has been done. That information is again communicated back to the driver program. The last one, we are having the cluster manager, which is responsible for acquiring resources such as CPU, memory, and storage, which I already mentioned, from the cluster and allocating them to the Spark application, of course. So example of cluster managers, there are few cluster managers which are well known and which is getting used in the Spark. Those are Apache Mesos, Hadoop yarn, and then Spark standalone mode itself. That means it's the own cluster manager, and these two are the other cluster managers, that are Hadoop yarn and then Apache Mesos. So this was whole overview of Apache, this architecture of Spark. And the last question anybody's mind it comes to, that where the PySpark then lie here. So PySpark is something which is getting communicated from here. This driver program, it is here. Which driver program? It is a code. So that code can be a Scala code. It can be the Python code. It can be the R code. Any code it can be, whatever it is provided. This PySpark or Databricks, whatever we are having, whatever it is giving us the API for whatever code we are having. Suppose we can give SQL code over here for the transformations. We can provide Python code. We can provide Scala code. Whatever code we will provide, so that will be something which will be taken by the driver program, and then further it will be executed. So this is where, when we write the code in Python, PySpark comes into picture. So that is the whole story about the architecture of Spark, Apache Spark, and how PySpark fits into this whole concept. It is something which I have explained right now. So this was whole about this video, and thank you so much guys for watching the videos. If any confusion, let me know into the comment section. See you in the next one.